This is Pre-Algebra Lesson 2.6, Solving Equations Using Multiplication or Division. In the last lesson, we learned how to use the subtraction and addition properties of equality to create equivalent equations. In this chapter, we'll learn to use the division and multiplication properties of equality. We'll begin with division. Whenever you divide each side of an equation by the same non-zero number, you produce an equivalent equation. For example, if 3x equals 12, then 3x divided by 3 and 12 divided by 3 will produce an equation that says x equals 4. These are equivalent equations. Thinking algebraically, if a times x equals b, and we divide each side by a to isolate x, x will equal b divided by a. These are equivalent equations. Let's work another example together that uses division. Negative 6x equals 48. If we want to isolate x so we can find its value, we need to divide each side of the equation by 6, negative 6, in fact. So negative 6x divided by negative 6 gives us an answer of x. 48 divided by negative 6 gives us an answer of negative 8. So now that we've simplified, we come up with a final answer of x equaling negative 8. If we wish to check our work, all we have to do is simply insert our negative 8 into our original equation. Negative 6 times negative 8 equals 48. Well, 8 times 6 is 48, and our two negative signs negate one another. So yes, indeed, we have 48 equaling 48. We did our work correctly. Just as we used the division property of equality to solve an equation that involved multiplication, we'll now use the multiplication property of equality to solve any equation that involves division. So if we multiply each side of an equation by the same non-zero number, we'll produce an equivalent equation. For example, x divided by 3 equals 12. If we wish to isolate x, we need to multiply each side by 3. 3 times x over 3 equals 12 times 3. So our 3's here cancel one another out, and we have x equaling 36. Let's solve another equation using the multiplication property of equality. Let's say that 9 equals w divided by 7. We want to isolate w to solve for its value. In order to do so, we're going to multiply each side of the equation by 7. Our 7's will cancel one another out, leaving us with only w. 9 times 7 equals 63. Therefore, the value of w is 63. Once again, you can check your work by simply inserting the value into your original equation. 63 divided by 7 does indeed equal 9, so we've done our work correctly. Try these 4 sample problems on your own. Problems 1 and 2 require you to use the division property of equality. Problems 3 and 4 require you to use the multiplication property of equality. Let's apply what we've learned about using division and multiplication to solve equations to solve this word problem. In 1995, the Solar and Heliospheric Observatory, or the SOHO, was launched into space. SOHO studies the sun, including high-speed gas called solar wind that is ejected from the sun and travels throughout the solar system. On a given day, the SOHO spacecraft detected solar wind traveling at about 2 million kilometers per hour. The sun is about 150 million kilometers from the Earth. About how long did it take the solar wind to reach Earth? We know that the formula for distance equals rate times time. We know two pieces of information here. We know the distance and we know the rate. Therefore, we can solve for the time. If t represents the time in hours it took the solar wind to reach the Earth, then we would write 150 million equals the rate, which was 2 million, times time, t. So in order to isolate t, we need to divide each side of our equation by 2 million. All right, that's a lot of zeros. The 2 millions will cancel one another out, leaving us with just t. And let's cross out all of our zeros here, because they all cancel one another out, leaving us with 150 divided by 2, which gives us 75. So it took our solar wind about 75 hours to reach Earth. That's all for today's lesson. When I see you tomorrow, we'll practice together, completing several problems where we use the multiplication property of equality and the division property of equality. See you then.